Okay, I think we will begin. Good evening, everyone, and welcome to our program here on June 3rd, sponsored by Metro West Climate Solutions. I am Jeff Barsnell, a member of the steering committee, and we are delighted you could join us tonight. Metro West Climate Solutions, or MCS, is a partnership of organizations and congregations in the region, including First Parish in Wayland, First Parish Church in Weston, First Parish in Lincoln, the Congregational Church of Weston, Sustainable Weston Action Group, and a growing list of community groups and individuals. Our mission is to encourage sustainable, resilient, and equitable action and host timely and relevant programs that inspire and inform people and communities to get involved in bringing about solutions. Tonight's program is being held in response to recent reports of toxic chemicals showing up in the drinking water supplies around the state and region. As many of us know, the town of Wayland discovered small but significant amounts of PFAS, or polyfluoroalkyl substances, in their drinking water last month. As a result, Wayland began distributing cases of bottled drinking water to 1,400 households each week, nearly one-third of the town's residents. This is a result of contamination detected at one of the town's wells that provides drinking water. Wayland, alas, is not alone in its predicament. Natick, Wellesley have both reported elevated levels of PFAS in their drinking water. In fact, 20% of the towns obligated by the state to share their test results of their drinking water systems have reported amounts of PFAS above what is deemed to be a safe level or concentration. It does need to be noted that this standard was lowered late last year by the Commonwealth based on the latest research and findings. There are a variety of questions that arise based on these new studies. And as we will hear this evening, PFAS are used in a variety of consumer goods, including nonstick pans, stain-resistant fabrics, plastic containers, and my current favorite, or not, certain fancy brands of dental floss. PFAS are called forever chemicals for a reason. They do not break down in the environment, and they hence accumulate in local ecosystems and watersheds. Tonight, we are fortunate to have staff members from both Clean Water Action and the Silent Spring Institute to present about the history and reality of PFAS in our communities and landscapes. Both of these groups have been at the forefront of raising awareness about the connections between toxic chemicals in consumer goods, ecological impacts, and human health. While this topic does not directly pertain to the climate, it is clear that this issue is yet another example of why human beings need to find ways to live in greater harmony with the natural world. Many of us on the board profess a respect for the interdependent web of existence of which we all are a part. And it is out of this truth that we offer this program tonight. While this is a webinar format, we encourage all of you to submit questions in writing by using the Q&A button on the lower bar of your Zoom screen. We will get to as many of the questions as we can with our panel of experts. Speaking of which, our host for this evening is the Executive Director of the Massachusetts chapter of Clean Water Action. I have known Elizabeth Saunders for almost 20 years and have followed and learned from her work in advocacy and many of her colleagues. Elizabeth joined Clean Water Action in 2001 and has worked on a variety of state, federal, and corporate campaigns seeking to reduce the use of toxic chemicals and prevent harm to human health and the environment. Because of Clean Water Action's work in the past, I can say personally that I threw away all of my Teflon pans many years ago and stopped buying pajamas for my kids treated with flame retardants. We thank Elizabeth for being here tonight, and we'll let her introduce our panelists, Laura Spark and Laurel Schaider. Good evening, Elizabeth.
Good evening, everyone. Thank you, Jeff, and thank you to the Metro West Climate Solutions for hosting this important conversation. I am so happy to be here. As some of you know, Metro West is my home turf as I grew up in Weston, so it's especially great to be with you all. Our first speaker tonight is Dr. Laurel Schaider from Silent Spring Institute. Silent Spring is the leading scientific research organization dedicated to uncovering the links between chemicals in our everyday environment and women's health. And we're very lucky to have their She's currently leading a study to evaluate PFAS levels in private wells on Cape Cod and identify contamination sources. Dr. Schaider has gained nationwide recognition as an expert on PFAS contamination and water quality, and tonight is going to give us a broad overview of the issues associated with PFAS exposure. So thank you and welcome, Dr. Schaider.
Hi, everyone. Thank you very much for the invitation to be here tonight. Thanks to the Metro West Climate Solutions Group, and thanks, Elizabeth, for that introduction. I'm just going to share my screen here. So I've been studying PFAS chemicals in drinking water since 2009, when we were studying unregulated drinking water contaminants on Cape Cod. Back in 2009, PFAS were not a household word, and they were not receiving nearly as much attention as they are now. So our work has focused not only on drinking water exposures, but also exposures from food and consumer products too. So my goal for tonight is to introduce you to this class of chemicals. I'll talk about what they are, why they're of such concern, and why they're gaining so much attention right now. I'm going to talk about PFAS in US drinking water supplies, and closer to home, what we know about PFAS in Massachusetts drinking water supplies. And then I'll end with some tips for things that you can do for reducing your PFAS exposure and ways you can learn more. And then I know Laura is going to go into a lot more detail about that after. So many of you may have seen this Boston Globe article that came out last Monday. This summarized the findings, as Jeff mentioned, that the state is now doing considerably more testing for PFAS in public water supplies because of a new standard that went into effect last October. And from these initial findings, we've learned that 20% of the public water supplies that have taken part in this testing that serve over 10,000 people have had at least one test above this new Massachusetts standard. So what are PFAS? So PFAS itself stands for per and polyfluoroalkyl substances, which is quite a mouthful. This acronym stands for a class of over 9,000 different compounds as identified by the EPA, or Environmental Protection Agency. Each one of these 9,000 compounds has a different chemical structure, but they're characterized by having many carbon-fluorine bonds. And this means that these chemicals, either their whole structure or parts of their structure, are extremely resistant to degradation. PFAS are also mobile in the environment, and they've been found in all corners of the globe, including in wildlife in the Arctic. PFAS have been used in consumer products since the 1950s, so these aren't new chemicals, but it's just really been in the past 5 to 10 years when they've started to get so much attention, due in large part to their widespread detection in drinking water supplies. So I'm not going to get too much into chemistry tonight, but I did want to give you a sense for what these chemicals look like in terms of their structure, and to introduce you to two of the chemicals that show up most frequently in the environment and in people's bodies. So up here on the right are two chemicals. One of them is PFOA, or sometimes called C8, and the other is PFOS, or PFAS. The O stands for octa, and that's because these chemicals have an 8 carbon chain in the middle of their structure. And you see all these Fs here, so those are the fluorines. So these have many carbon-fluorine bonds. These are some of the strongest bonds in chemistry, and they don't really break down under regular conditions. So you can see that these two chemicals have very similar chemical structures, with some differences in terms of what's at the end. These are what we call long chain PFAS. So these two in particular are actually not produced in the US anymore, although they are extremely persistent as contaminants in the environment. In their place, they're being substituted with other PFAS chemicals. Some of them are just shorter versions of PFOA and PFAS, and some have other different types of chemistries. If you haven't already, I would recommend that you watch the film Dark Waters with Mark Ruffalo and Anne Hathaway. This is about a community in West Virginia that was contaminated by PFOA, or C8, from a DuPont factory, and a lawyer, Rob Bilott, in his heroic efforts to get justice for the communities that suffered from that contamination. So sometimes people ask me, like, so what's different about PFAS? Are they really so different from all the other chemicals that we have to worry about? And they do have a combination of really challenging properties. So as Jeff mentioned, they're called forever chemicals because of their extreme persistence in the environment. They're mobile, so they've been found all over the globe. They can bioaccumulate both in people and in wildlife. From what we know, they're toxic. Most of the 9,000 PFAS have not been extensively studied for health effects, but what we do know about them raises a lot of concerns about their toxicity. And they're versatile. They're used in many everyday products. So certainly other pollutants have some of these characteristics, but I would say that PFAS are somewhat unique in terms of having all of these characteristics within one family of chemicals. So PFAS may not be a household word, and you can't usually find PFAS on product labels, but some products that are very familiar to us contain PFAS. So for instance, products that say Gore-Tex, Scotchgard, Stainmaster, or Teflon all have PFAS, but they also show up in products that don't have words on their label that might clue you into whether they have PFAS. For instance, microwave popcorn bags or pizza boxes, many types of furniture with stain-resistant treatments, floor waxes and ski waxes, even certain types of dental floss like Oral-B Glide dental floss, paints, and I'm always learning new uses for them. The most recent ones I learned about were guitar strings and climbing ropes. So most of my work at Silent Spring has focused on drinking water quality, but our work also extends to PFAS exposures from diet and consumer products. We led a study in 2017 that documented the prevalence of PFAS in fast food wrappers across the country. Our work has shown that what we eat can affect the PFAS levels in our bodies. We found that people who ate out more tended to have higher PFAS levels in their bodies. And we also found that people who used Oral-B Glide dental floss or had stain-resistant carpets in their house also had measurably higher PFAS in their bodies. So not surprisingly, because of their widespread use, their persistence, and their ability to accumulate in people's bodies, PFAS exposures are ubiquitous. According to testing by the CDC, over 99% of Americans have detectable levels of PFAS in our bodies. Some of these PFAS are extremely long-lived in our bodies. So long-chain PFAS, like PFOS and PFOA, can stay in our body for years. The newer substitutes don't stay in our bodies for quite as long, but they still can have moderately long half-lives in our bodies. So that refers to the amount of time that they stay in our bodies for weeks to months. And that's quite long compared to something like a medication or a drug that you might take, which can be cleared from our body over the course of just a few hours. And really, we don't have a lot of information about the behavior of most PFAS. So I'm going to talk a bit about what we know about the health effects associated with PFAS exposures. And first, I wanted to talk about how we learn how chemicals can be toxic. So some studies focus on exposed human populations. In some cases, these are communities where there's been a local source of environmental contamination. For something like PFAS, which basically all of us have been exposed to, some of these studies look at the general population as well. So these are epidemiological studies. The strength, obviously, is that they're done in people, and so the results are really directly relevant to understanding people's health. The drawback is that they take a lot of time and that we miss a window for prevention. If we do a long study of chemical exposures in people, we find out something's toxic. We've missed a chance to reduce those exposures because it's kind of too late. Other types of studies, a lot of what we know about harmful effects of chemicals come from laboratory studies, what we call toxicological studies. These allow us to make a much more direct link between one specific chemical and a health outcome, but there can be differences in how chemicals affect laboratory animals versus people. And then there are an increasing number of other types of laboratory studies, what's called in vitro testing, where you can have dishes in the lab that have cells or different parts of our biology basically in a cell, so that we can really screen many more chemicals quickly, but there can be limitations in terms of how directly they're relevant to people's health. And really, when we have multiple lines of evidence, that gives us more strength in the association between a certain exposure and a health outcome. So most of what we know about PFAS toxicity has focused on PFOS, PFOA, and a handful of other PFAS chemicals. Some of the health effects that have been associated with PFAS exposure include testicular and kidney cancer, thyroid disease, elevated cholesterol, decreases in birth weight, ulcerative colitis, preeclampsia, and something that's getting a lot of attention and raising a lot of concerns lately is immune system toxicity. In particular, studies in the Faroe Islands conducted by my colleague Philippe Grandjean from Harvard University have found that children who have higher exposures to PFAS seem to have less of an immune response to routine vaccinations. Obviously, with COVID right now, people are thinking so much about vaccinations, and there are studies underway to evaluate whether people who've had higher PFAS exposures might be more susceptible to COVID. I want to stress that there's no evidence right now that COVID vaccines are any less effective in people with higher exposures, but it is an area of active research. So how can we be exposed to PFAS? So PFAS are not naturally occurring. So all PFAS originate from a chemical manufacturer. We can be exposed from consumer products, so directly through using these products in our homes or workplace, breathing in PFAS, if you're a kid and you get your hands all over your furniture and then lick your hands, or from dust, which is another common way we're exposed to chemicals in our home environment. Another common source of environmental contamination is a certain class of firefighting foams called AFFF. These are commonly used at military bases, airports, and other fire training academies for fighting fuel fires. These can be a common source of water contamination, and environmental contamination can lead to human exposure, both through drinking water and from food, because plants and animals can accumulate PFAS from their local environment. And increasingly, the role of the waste stream as a source of environmental contamination is being recognized as well. So in communities that have water contamination, that's often thought to be the largest source of exposure, but we can be exposed from food and from consumer products. And the relative importance of those two sources has not yet been well characterized. So specifically focusing on drinking water contamination and other contamination sites, the Environmental Working Group has been tracking contamination sites across the country. And I always have to update this map because they're always finding evidence of more contamination sites. So this was their most recent map where they documented over 2,000 sites in the US with environmental contamination or PFAS in drinking water supplies. And they estimate that over 200 million Americans have some level of PFAS in their drinking water over 1 part per trillion. So you might look at this map and say, wow, there are some states that have so many dots. Are they really a lot more contaminated than other states? And I did want to mention that states like New Hampshire, Michigan, New Jersey, and North Carolina have more dots because they have conducted more extensive testing. And as Massachusetts conducts more testing of water supplies, my guess is that we may see more dots appearing in Massachusetts as well. So I've mentioned the firefighting foams, AFFF, as one common source of water contamination that has been linked to some of the sites that have the highest levels of PFAS. Other sites with high levels of PFAS are close to fluoropolymer production facilities. So near DuPont, 3M, or other chemical industries that produce PFAS. High levels have also been found near industrial sites where PFAS are incorporated into products. So for instance, in Hoosick Falls, New York, or Merrimack, New Hampshire, or Bennington, Vermont, where St. Gobain plants created Teflon-coated products. Lower levels of environmental contamination are also associated with waste sources. So for instance, discharges from wastewater treatment plants, septic systems, and landfills, as well as locations where biosolids or sludge from wastewater treatment plants is applied to the land. And I wanted to just mention that sometimes when we look at the exact composition of specific PFAS chemicals, that can provide some clues about the possible sources. So here I'm just showing some pie charts with the levels of 5 different specific PFAS chemicals. Here are 2 sites where firefighting foams are thought to be the main source. So in Hyannis on the Cape and at a site in Pennsylvania. I won't get into the specific chemical names, but you can see the yellow and the orange pieces of the pie are much larger here. And that's because these two chemicals are relatively abundant in firefighting foams. By contrast, these are two sites associated with Teflon related sources, and you see that they have they're dominated by different PFAS chemicals. So it's not a perfect tool, but it sometimes can provide us some clues about what is the most likely source in an area. So in terms of drinking water regulations, even though these are widespread contaminants and they raise many health concerns, there is currently no federal drinking water standard for any PFAS chemical. So that means that on an ongoing basis, there's no testing required by public water supplies and no requirement to meet a certain standard. The EPA did issue a non-enforceable lifetime health advisory for the total amount of two specific PFAS chemicals, the two I've mentioned before, PFAS and PFOA, and they set that level at 70 parts per trillion, and that's the same as 70 nanograms per liter. They set the standard, or sorry, this guideline in 2016, and this is quite a bit lower than their previous advisories, which they had set in 2009 of 200 parts per trillion for PFOS and 400 parts per trillion for PFOA. So it's almost 10 times stricter than it used to be. Many scientists and a variety of state regulators have concluded that this EPA guideline doesn't go far enough to protect people's health. 12 states have enacted or proposed stricter regulations. Some of these are stricter because they are enforceable standards, which means that water supplies have to do testing and they have to take steps to make sure they stay under the value. Some states are including other chemicals beyond just PFAS and PFOA. Many of the most recent standards are in the range of 10 to 20 parts per trillion. Sometimes this applies to one specific chemical and sometimes to a combination. So that's quite a bit lower than 70 set by EPA. And these regulations often result in stricter monitoring requirements. So Massachusetts is one of these 12 states. Last October, they enacted an enforceable standard, which is called a maximum contaminant level. And it's among the strictest across the country. And it's called the PFAS 6 MCL because it refers to the total amount of 6 PFAS chemicals, PFOS, PFOA, and 4 related compounds. And the level is set at 20 parts per trillion. So that's quite a bit stricter than the EPA advisory level of 70. The regulation also establishes a sequence of testing requirements, and the largest water supplies in the state had to start testing earlier this year. And then there's been a phase in of testing requirements for smaller water supplies as well. And if water supplies detect over 10 parts per trillion, that triggers more frequent testing, and levels above 20 require actions to make sure the water stays below that standard. Importantly, the regulation also includes financial support for public water supplies. It's important to recognize that testing for PFAS and especially treating PFAS is very expensive. And so it's important to have this kind of support to address the needs of water supplies. And the regulations also include a provision to review new science every 3 years. There's a lot of emerging science about PFAS chemicals, so it's an important part of this regulation to review this new science to evaluate whether the level is set low enough and whether it's appropriate to consider additional chemicals as well. So what have we learned so far? So from the results of the testing that's been done of public water supplies in Massachusetts, 614 of the public water supplies have been tested so far. So that's out of a total of 1,600 public water supplies. So of these 614 that have been tested, 51 have found a level of PFAS 6, so again, the sum of those 6 chemicals, above the standard in at least one test. So that doesn't necessarily mean that the tap water throughout that whole distribution system is above 20, because the water in your tap is usually a mixture of water from different sources. So many of these water supplies are municipal or town water supplies, but some are smaller public water supplies that serve schools, condominiums, businesses, or other institutions. So if you're curious to learn more about your community, there's a website that you can go to. It's kind of a long website, but you could also probably Google it. And it's got a nice, it kind of nicely lays out an introduction. It provides information about the testing. And then you can look up whether testing has been conducted in your town. They have a list of all the water supplies where PFAS have been found over that 20 part per trillion standard, and information about the responses. So this is kind of a zoomed out version. I zoomed in a little bit. Again, I know that there are concerns specifically about Wayland, so I learned a little bit about what's been found in Wayland. So you can click on that dot on the website and it'll give you more information. So I did dig a little deeper because I was curious to know more about what's been found in terms of PFAS in the Wayland public water supply. And there may be others on this call who are much more familiar with the specifics of the Wayland water supply. But from what I've learned, there are public wells pulling from 4 different parts of town. Sometimes this is one individual well, and sometimes it's a cluster of wells close by. And so far, the results have been mixed in terms of the levels. So this is showing the PFAS 6 level in 1 or 2 water samples that have been collected from the wells throughout the town. The wells that had the highest levels are here, the Happy Hollow wells. These are the ones that fell above that 20 part per trillion standard. In the northern part of town, the levels were lower, although you can see it doesn't necessarily follow a trend. So the Chamberlain well here in the middle had levels not above 20, but closer to 20, whereas the wells further north and south of there had levels around 3 parts per trillion.
Okay, looks like we're having a little bit of technical difficulty. It wouldn't be a Zoom event without some frozen, without some technical difficulties. I think Laurel has dropped off the call. So perhaps why don't we go ahead to Laura Spark, and then we'll have Laurel come back and finish her presentation. Laura Spark is the Senior Policy Advocate at Clean Water Action in Massachusetts. She coordinates Clean Water's state advocacy campaigns focused on environmental health. So Laura's an advocate for the precautionary policies that reduce health impacts of toxic chemicals in consumer products and the environment. And she's leading our organization, Clean Water Action's work to eliminate PFAS from consumer products.
Okay.
And it looks like we still do not have Laurel, so I'm going to go ahead and hand it over to Laura. Take it away.
Okay, I am going to share my screen, but I noticed that there are a couple of Q&As, really good questions that Laurel is the best person to answer. So I see them there. I am not going to answer them because, oh, she's back.
She is back. Maybe.
We're going to go back to Laurel.
I'm really sorry about that, the joys of virtual presentations. I don't know where I lost you exactly.
You were on the slide with the 4 Wayland wells.
Okay, great. Let me just share my screen. Okay, great. Are you seeing my slides?
Not yet. It's black.
Oh.
There you go. It's there.
Okay. All right. Well, feel free to give a holler again if something that goes wrong here. So here we can see that there are wells in 4 different parts of town. And sorry if this is a repeat. I don't know where I lost all of you. And when we look at what the PFAS levels are like in these 4 different parts of town, we see that there's quite a range. So the Happy Hollow wells, which are the ones on the south side of town, are the ones that had PFAS above the standard. This green area here shows the area of land that potentially contributes groundwater to this well. In the northern part of town are 3 different wells, and you can see that there's no clear trend. The ones with the highest levels of these 3, around 16 parts per trillion, are in the middle, and the ones above and below that are around 3 parts per trillion. So I wanted to show how these levels look when we look at each of the chemicals individually within the 6 that are regulated within the Massachusetts standard. So what I'm showing here is the sum of the 6 PFAS The purple line shows the Massachusetts drinking water standard of 20 parts per trillion. And these are the 4 different wells or well fields that have been tested either once or twice. And so what you can see is that there's kind of a mix of different chemicals. The yellow and orange ones are the ones that are typically higher in an area with a firefighting foam source. And the bluer ones are usually associated with industrial sources. And I'd say from this that there's not a clear source that kind of stands out from here. And perhaps others on the call who are more familiar specifically with Wayland may have more information about local sources. I did also want to put these results into a broader context of PFAS levels in other water supplies. So I'm going to take this one water sample here, the highest one, and compare it to the highest ones that have been found in other water supplies in Massachusetts, many of which discovered their contamination earlier and have already gone to great lengths to address the PFAS contamination. So now this is going up to 800 parts per trillion. So we've zoomed out quite a bit. This purple line here is the Massachusetts standard. Here's that bar from Wayland that I just mentioned. And the green line is showing the EPA's 70 parts per trillion guideline. And so what you can see here are the highest levels that have been found in untreated water from other water supplies actually are quite a bit higher. And in some cases were above the levels set by EPA in 2009, which were in the hundreds of parts per trillion. These don't represent the conditions right now in these towns. These are all areas where activated carbon treatment or other types of treatment have been put into place, or contaminated wells have been taken offline. But I just wanted not to minimize what's happening in Wayland at all, but just to put the results into a context and let you know that other communities have had even greater challenges with PFAS. Some of you may have a private well, so you might want to know whether there's any way that you can find out information about PFAS in your private well. In general, there's not much information about PFAS in private wells, but the Department of Environmental Protection is offering a testing program right now. This is open to private well owners in 84 towns in Massachusetts, in which 60% or more of residents are served by private wells. So in the Metro West area, I pulled out a few, Carlisle, Harvard, and Stowe, and there's a website where you can sign up if you're interested. I don't know if everyone who is eligible will get their water tested. My understanding is they're picking a subset of wells in each of these towns. We've done some work on Cape Cod looking at PFAS in private wells, and I'm happy to talk about those results later if anyone has any questions. So a question that I often get when people learn about PFAS in their drinking water is, what are the options that might be available to me if I wanted to do something in terms of water treatment in my own home? And there are 2 general types of filtration systems that people consider when they're looking at PFAS in their drinking water. So one type of filter is based on activated carbon. This can be like a solid carbon block filter, which is typically installed under someone's sink. It's a little special little faucet, or a filter pitcher, which has those bigger kind of black pieces of activated carbon. Typically, solid carbon block filters are more effective because they have more surface area. Activated carbon filters are generally considered very effective for PFOS, PFOA, and other long chain PFAS chemicals. The short chain PFAS, so the replacement chemicals, are not as well removed. And there are a lot of variations in that, but in general, they tend to, the filter can be effective for them early on. And then as the filter gets older, the short chain ones start to be able to break through earlier. The other type of treatment that people often consider for PFAS is reverse osmosis, which tends to be effective both for long chain and short chain PFAS. There's definitely some drawbacks to reverse osmosis. It's more expensive and it generates a waste stream. So for every gallon of water that's treated, there are several gallons of wastewater. So typically this would be something just at the point of use and not something you would do for your whole house, because that would be really a lot of wastewater. And if you're on a septic system, having all that extra water can affect the performance of the septic system. So Laura is going to talk a lot more about things that you can do and ways you can reduce your exposure, but I wanted to mention a few things based on our research and on other research studies. Some examples include avoiding stain-resistant carpets and upholstery, It's really difficult, and it really shouldn't be up to individuals to have to try to find words on labels to avoid toxic chemicals like PFAS. But if you do see anything that says perfluoro, polyfluoro, or PTFE, this is the chemical name for Teflon, those are ways you can avoid buying PFAS. Eating more fresh foods to reduce the contact between your food and packaging, minimizing your contact with fluorinated ski waxes. And if your drinking water does have elevated levels of PFAS, you could consider filtering your water. And just as a kind of general rule of thumb, when you're shopping for items, you can ask yourself, like, is this something that I really need to have this feature? Do I really need it to have PFAS? And I'd recommend you try out our Detox Me smartphone app, which has tips on reducing exposures to PFAS and other toxic chemicals. For more information, there are a couple of websites I'd recommend. This is the PFASexchange.org. This is a resource that we're developing as part of a study called PFAS Reach. It's got fact sheets, including tips on water treatment systems, resources for PFAS affected communities, and a tool for interpreting results of water and blood PFAS testing. You can also look at the STEEP Superfund Research Program's website. This is led by University of Rhode Island, and Silent Spray Institute is a collaborating research partner, which also has resources on water treatment and tips for reducing exposure, as well as research updates as well. So with that, I'll share my contact information and a few websites, and looking forward to the questions. And again, sorry for the internet gap here. So thanks.
Elizabeth, there are a couple of questions that I'm wondering whether I think maybe it makes sense to go over those before hopping into my presentation. Because I think
I think let's just, in the interest of time, let's make sure we do your presentation so we finish the presentations by 8. So if that's okay. So I've already introduced Laura. So Laura, if you want to turn on your video and take it away.
Okay. Obviously, PFAS are ubiquitous. They're in all of our blood, and they're a really concerning class of chemicals. So where does that leave us? What can you do? How can you protect yourself and take action to address PFAS? So this is what I'm going to talk about. I'm going to talk a little bit about reducing personal exposures very briefly, because Laurel went over it, and some of the material is stuff that you can find online. I can give you some websites. I'm going to talk about taking action locally around water contamination, statewide advocacy to change the situation, what we're hearing about what is happening in DC, and then I'll give you some options to take advocacy action. So personal exposures. Again, as Laurel mentioned, one of the major places that we are seeing people be exposed to PFAS is food packaging. And food packaging is concerning for the obvious reason, for actually sort of 2 reasons. One is that when PFAS is added to food packaging, the chemicals don't sit there. They transfer into the food we're eating and then into us. This happens particularly when you're eating food that is hot or fatty. Now, the reality is that we all use takeout, takeout food, and it is difficult to know, and in some cases it's really impossible to know whether the specific packaging that you're using has PFAS or doesn't. So a couple of tips. One is, and I think some of these came initially from Silent Spring, is if you're using takeout, I'm using takeout tonight, take the food out of the wrapper or container as quickly as possible. Don't use a wrapper as a placemat, which I remember doing all the time at McDonald's years ago. Don't store food in takeout containers like the Chinese food in the takeout container. Just limit the time that your food is exposed to the packaging. Know that PFAS can be in any paper-based food container and packaging, including candy wrappers, cake plates in bakeries. It's in wrappers around hamburgers and in French fry boxes. It's in plates and cups, and one place that we've seen a lot in clamshells, which is what you see on the top, sort of like that kind of takeout container that opens and shuts like a clamshell. One place where we have seen PFAS very frequently is in something called compostable molded fiber. And if you look at the bottom, that drink container is compostable molded fiber. It often looks eco-friendly. It looks like sort of wood and some water have been mixed together and then applied to a mold and dried. So that is one way that PFAS can be used. It can be added to that slurry and dried, or it can be applied like a coating. So as studies have shown, like the Silent Spring study, about 40% of food packaging has PFAS and 60% doesn't. Up until recently, literally just within the last year, all of the molded fiber products did have PFAS in them. And so there was testing about a year ago. You may have followed this in the media that found PFAS in a range of food wrappings in fast food chains, and found actually higher and more PFAS in chains like Sweetgreens and Freshie and Cava, the sort of healthy chains. And that's because they're using those molded fiber bowls. Because of pressure that was brought to bear on those companies from a group that we're involved in called Mind the Store, a number of the larger chains have made pledges specifically to get out of using PFAS. Using food packaging with PFAS. So Whole Foods, which had PFAS in its takeout containers by the salad bar, no longer has food packaging with PFAS. Trader Joe's also does not have packaging with PFAS, and a number of takeout venues. Wendy's is going to get out of it by PFAS and food packaging by 2021. Sweetgreen eliminated PFAS from its food packaging in 2020. Chipotle and Cava are getting out by mid-2021. Stop and Shop doesn't have any PFAS in its store branded food packaging. And you can find some of that information at Mind the Store. But if you're not going to sort of a large chain store, it may be impossible to know. So you just want to limit the amount of time that your food is in contact with food packaging. One of the other problems that we find with PFAS in food packaging is, of course, that food packaging is made to be used for a very short amount of time, while PFAS, of course, has been dubbed the forever chemical. It is persistent and remains in the environment for thousands of years. So what happens when after you've eaten your hamburger, for example, you throw away the wrapper and it either lands in landfill or in compost. One of the problems that we are having and have not really fully gotten a hold of is that compost has become contaminated by PFAS containing food packaging. So again, there have been tests done of compost coming out of home composters, which find very little PFAS, and then compost coming out of commercial composters, including organic compost, finding varying levels, but much higher amounts of PFAS. So when compost is applied to plants, and I think this was one of the questions, plants do absorb the PFAS, and then the PFAS in the plant, if it's a vegetable, gets ingested. So a number of composters are now requiring all packaging waste to be certified as PFAS free, but there was an issue of the legacy PFAS on their sites. So that is an issue just to stay aware of, because it's not yet clear how we're going to kind of solve this problem in the compost industry. One thing that is clear, however, is that fertilizer made of residuals, which is human waste, which is treated and then often sold as a fertilizer, that very likely does have PFAS. So a study just came out this month from the Ecology Center in Michigan, found that 9 out of 9 fertilizers made with residuals contained between 14 and 20 PFAS. That included Earthlife, which is made and sold here locally in Quincy, and also Baystite fertilizer. They both are using sludge from MWRA. You want to avoid those. So when you go to the garden store, look, see if it's made from residuals or sludge, and do not buy those products. Another thing to be aware of, and which is challenging, is that because the ocean waters and surface waters have been contaminated, is that fish and seafood may also have PFAS. And there are some sort of highly publicized situations in which milk dairy farms or meat has also been contaminated, although that's been found less. And in those cases, there are farms where residuals with very high levels of PFAS were applied. So in this case, you just want to pay attention to food advisories. Is there a food advisory on the kind of fish or shellfish that you eat? And make sure that if there is, that you're not consuming that type of shellfish or fish. Next thing, as Laura already said, this is an easy thing to avoid. You want to not use anything nonstick or waterproof. PFAS is applied to textiles, with furniture, textiles, and clothing, wide variety of products, and you don't want to use those if you can. PFAS can either be in the product when it's sold. They may offer you, do you want a stain resistant finish? Or it can be sprayed on afterwards by people, but you could buy, a spray and spray it onto textiles. It's important to avoid that. You will see a lot of outdoor furniture. I have outdoor furniture that likely has PFAS on it because it's waterproof. Those things you want going forward, you want to not buy. Also, jackets, raincoats, umbrellas, most outdoor gear, hiking gear, anything with Gore-Tex, my shoes and sneakers, high performance gear will all have PFAS. Another thing to be aware of is school and work uniforms, again, if they're stain proof. And really think about any textile that may be stain proof or waterproof. Tablecloths, mattresses, mattress pads, bedding. We find bibs and face masks. All of these things, if they're waterproof, if they're stain proof. Again, there are other ways of making products waterproof and stain proof, but PFAS is very widely used. And for now, these are things that you want to avoid. Next, as Laurel has already said, there are some personal care products that have PFAS. The one that's gotten the most play, of course, is dental floss. Silent Spring already mentioned that they did a study that showed that women who used Oral-B Glide, which I used for many years until I read that study, had higher PFAS levels. You can find PFAS-free dental floss by going to Because Health is a good website that lists PFAS-free dental floss. That they're often the kinds that you might see at a natural food store, like a Tom's of Maine does not have. To give a Desert Essence, those are two examples. Some other cosmetics may also have PFAS. So you want to avoid anything with PTFE, or that, as Laurel said, starts with perfluoro. And Skin Deep is a resource that you can go to look up products. The main products that may have PFAS are mascaras and foundations and concealing creams. One other product that sort of new to the market, menstrual underwear. 11 out of 17 brands tested this month in a small study did have PFAS, with 3 having very high levels. And again, because of the exposure to a vulnerable part of the body, that is something that either don't use that underwear, or there's some products that do not use PFAS, and you want to do research on that before you use those products. Obviously, we often talk about PFAS as the Teflon toxic, and nonstick cookware is a major place that we see PFAS. A couple of things to be aware of. One of the things you may have seen, I know I've seen it in kitchen stores, is you may go into a kitchen store and see a product advertised as PFOA or PFOS free. That is actually very misleading. PFOA and PFOS are the 2 original chemicals that were synthesized in the 40s. They haven't really been used in the last a little bit more than a decade. They're still in the environment, but new PFAS are what are being used. So a product can advertise itself as PFOA or PFOS free and have other PFAS in them. California is trying to do a sort of accurate labeling law to change that, but that has not happened yet. So cookware is another thing that you want to, if you have nonstick cookware, it's something to get rid of. You're exposed to it. Your food, it's in the air. You may transfer into your food. When you get rid of it, unfortunately, it will also remain in the environment. And there's some concerns that have been raised recently about what happens when you wash cookware. Certainly some cookware, if it's older, may be flaking or chipped, and that's something you definitely do not do not want to use, because that's making the PFAS more available. One of the other concerning things about PFAS, and we're going to in a minute go to solutions, is that the more we look for PFAS, the more we find. Even what we're talking about tonight is just some of the products that have PFAS. In building products, particularly if anyone's on this call as an architect, almost anything you can think of has PFAS. Most roofing of all different types, whether it's metal or asphalt or membrane, glass, paints are a very widespread use of PFAS. And it's very difficult to find out if your product has PFAS in it. It doesn't say. Grouts, sealants, plumbing tapes, electrical supplies, HVAC components, and for many of us on the call, a particularly unhappy use is solar panels. It is used in a variety of different aspects of solar panels, different layers. It makes them more resilient. It's also used in lithium batteries, so that is something we are going to want to dig into and look at. But it is definitely in solar panels. Now, obviously, the PV on your roof, if it's on your roof, it's not going to necessarily hurt you right now, but at some point, you know, it's going to come to the end of its life. We're going to be using more PV panels. We want to address the use of PFAS on solar panels. Again, coatings, also composite woods, and coatings for metal, plastic, wood, really almost anything you can think of in the building product world. Artificial turf is, PFAS is used there. It's not added into the product, but it gets in the product because it's in the machinery that sort of stamps out the little pieces of grass. Cleaners, solvents, and waxes are other places where we see PFAS. One thing to be aware of, it's maybe in floor waxes or cleaners, including ones that might be used in your schools or your workplace, and that's another place where you might want to do advocacy, and it's in pet products. So it's everywhere. And the problem is the more we look for PFAS, the more we find PFAS. So what do you do? The first thing I want to talk about is obviously some people on this call are from Wayland. If you are in a town that is not yet tested for PFAS, you want to contact your local water department or town manager, ask if they've begun testing for PFAS. If not, find out when they're planning on testing and submitting results. If you are in a town that is PFAS, 6 PFAS over 20 parts per trillion, such as Wayland, Bedford, you can contact the Mass Department of Environmental Protection to find out if they've identified a source and responsible party. The party responsible for the contamination is responsible for addressing the cost of contamination. And as I think people on this call already know, there are a variety of options for addressing contamination, taking the water source offline, connecting to a new water source, treating. 2 things to be aware of and to work on at the local level. If you were given bottled water, most bottled water is not tested for PFAS. One of the things that we are asking as part of our state advocacy is for the Massachusetts legislature to require bottled water to be tested for PFAS, but you should ask. And if it hasn't been, it should be. Also, if you're kids in schools, ask them to eliminate PFAS in food serviceware. One particular area of concern is a lot of schools use these molded fiber trays where hot food is placed directly on the tray in sort of different compartments. That's not a good idea. And that is, if that's happening in your town, that is something you want to advocate for a change. Similarly, PFAS-free cleaners and waxes used on floors will be in the environment that's something you want to avoid. For local level, clean water our focus is state advocacy, but if you want help organizing or working on any of these things, Community Action Works is another nonprofit that their sole focus is helping communities organize locally to address contamination. They organize a national PFAS coalition, and Shana Kaspar, her contact information is on the slide, is a person you can contact who will work with you. And she asked me to mention her tonight, so that she is anxious to, or not anxious, but she's very ready and willing to work with people in Wayland or other towns who are facing contamination. So what else can you do to actually change the situation? Our focus at Clean Water is to to change the conditions that are causing us all to be exposed to toxic chemicals. This year, a lot of action on toxics for a variety of reasons has really focused on state advocacy. This year and this session, so over the next 2 years, we're really focusing on multiple bills to doing what we're calling turn off the tap. We want to stop using PFAS whenever we can. Our belief is that we can't stop PFAS contamination if we don't stop making and using products that contain PFAS. Also last year, an interagency PFAS task force was created, which brings together state officials and legislative leaders and some outside consultants to specifically address water contamination. And the people who are involved in that task force have said that they want to put out comprehensive PFAS legislation by the end of this year, December, and position Massachusetts as a leader. So this is a little unusual for us. Usually we're just trying to pass bills, but what we're going to do now is we're going to try to pass the bills that I'll talk about in a minute, but also trying to interact and work with the PFAS task force and encourage impacted communities to interact with that task force to push for action that may go beyond what we have proposed in bills. So this specifically is what we are proposing, and we would welcome your involvement and engagement, speaking out, talking to your legislators later on any of these. These are our two top priorities. We want to ban PFAS in food packaging, and we think that's a no-brainer. As Dr. Schaider's studies have shown, plenty of food packaging can be safely and economically made without PFAS. We don't need PFAS in food packaging. We shouldn't have to guess if our lunch is safe or toxic, and we just want to get rid of it. We have a bill to ban the use of PFAS in food packaging, and we are hoping that you will support that and let your local legislator know that this is something that an action you want them to take. Separately, we have another bill that is addressing a lot of the other exposures, not all of them, but a number of them that we just talked about. We are trying to ban PFAS from being used in carpets, rugs, furniture, textiles. So that's the outside, water-free furniture or inside stain-free upholstered furniture and aftermarket sprays. Our legislation also bans PFAS in all the personal care products we've mentioned, including floss and in cookware. We expect actually the fact that we have put cookware in there is going to make it very hard to pass that bill. We've got a hearing coming up at the end of the month, and that is another place where letting your legislators know that you do not want PFAS if it's not needed. It's going to be very important. There are three other bills that we are supporting that others have introduced. Two that others have introduced, one that we've introduced. One is a bill to get PFAS out of firefighters' personal protective equipment. The professional firefighters are leading that. Another, you've probably followed some of the news about PFAS and pesticides. We want to ban the use of any pesticides with PFAS in Massachusetts mosquito control. And last, we have a slightly more complex bill called the Massachusetts Toxic-Free Kids Bill that broadly requires the disclosure of any requires a disclosure of toxic chemicals on a list that the state creates, so a list of chemicals of concern. It requires manufacturers to disclose when those chemicals are put in products sold to children under the age of 12. It also requires, in the House version, for the most toxic chemicals like benzene and formaldehyde and arsenic and asbestos and lead, and mercury, and also PFAS to be removed from children's products. So just coming quickly back to the Interagency PFAS Task Force, while we have these bills and they were introduced in January and they're moving forward, you might notice that none of them really address water. And part of the reason for that is that the PFAS Task Force specifically said to other legislators, we want to take on water. We want to be the place where water is addressed. So Clean Water Action, with a group of about 15 to 20 other environmental and public health organizations, including some people from impacted communities, have sent recommendations to the task force to ban PFAS in firefighting foam. I guess some of Hanscom is here, to not just ban a few products like the bills that we just mentioned do, but to ban all uses of PFAS unless they are essential for health and safety. We don't know that that will get through this year, but we think that that is the way that Massachusetts and the United States should go. In 2019, the European Union pledged to eliminate all uses of PFAS within 10 years, unless those uses were essential for health and safety. A fraction of the uses of PFAS are essential for health and safety. They may be, medical devices, masks, some other uses, but most are not. And so we are advocating for banning all uses. The other important things that, as you know, there needs to be money for water treatment, health and medical monitoring for people who might be disproportionately impacted. And also, we are concerned that PFAS is not just in the water, but because it's in contaminated compost and biosolids, and because there isn't currently any safe way to dispose of PFAS, that contamination is going to continue. So we are we've made other recommendations that would prevent the spread of PFAS through other environmental media. And finally, many other states have, their attorney generals have filed suit against PFAS manufacturers to require them to pay for the damages and cost of cleanup. Manufacturers are fighting that very hard, but we think that at the end of the day, they need to pay for it rather than the taxpayers. So we are asking you to speak up. It is very important that legislators know how concerned you are about PFAS. There are people in other communities that haven't yet had their water tested, may not yet know that they are impacted. Even if you don't have contaminated water, you are impacted. People who do know that they are impacted really do need to let their legislators know that you're concerned about PFAS, you want action on food packaging, you want action on consumer products and the other bills. We have an action alert that you can just click on and send it takes less than 2 minutes. You can just click on it and send a message asking your legislator to co-sponsor and support the 4 bills that I mentioned earlier. Or if you have more time, a personal email does get more attention, even if it's 3 sentences, and you write to your legislator and say, I'm concerned about this. This is why I want you to take action, and mention the bills you want them to co-sponsor and support. That is very impactful. Secondly, because there's the option of talking to the task force, you can and should communicate directly with the task force. You can do that by sending a letter to the chairs, Representative Hogan and Senator Sear. Their contact information is on that legislature.gov website. You can also talk directly to your legislator and tell them what you want from the task force. Those are sort of 2 avenues of reaching the task force and letting them know what you think is important, what you think the state should do. So, because it's been a little bit long, I am going to very briefly, not going to kind of go into details on this, other than to say that a number of PFAS bills have been introduced at the federal level. Whether they pass or not it's challenging because of the national dynamic right now. And I think for us, one reason to really focus on state action is not just that the national dynamic is challenging, but that we already know that we have champions. Markey, Warren, and others are very good on environmental issues. If there is an opportunity to push on any of these bills, some of which provide more funding, some of which provide more limitations on what manufacturers can and can't do, that's something that we will send out in action alerts. But for now, where we really think that we're going to be able to get traction is at the state level. If you want to work with us, we want to work with you. We have send out action alerts whenever things are moving, legislation is moving forward. We have a website where you can get updates on any PFAS information that's in the news. You can follow us on social media, and just more personally, you can just email us. And if there's anything that you want to do on the state level that you need support on, if there's any information you need that you don't have, we will either have it, or if we don't have it, we will find somebody who does have it. And we are really looking forward to working with you. And that is it.
Great. Well, thank you very much, Laura, and thank you, and Dr. Schaider, and thank you for all of the excellent questions that you all have been raising. There are way more questions than we can possibly answer. So Laura and Dr. Schaider have answered some of them in the Q&A in writing. So you might want to check there because, but a couple that we haven't responded to in writing. Is PFAS a danger only for water ingested, or can it be absorbed in showering and bathing? Does it become atomized and inhaled? Dr. Schaider, do you want to answer that question?
Sure, I'll take a pass at that. So it's a great question. I'm not aware of studies that have really directly looked at this. I would say that in general, people do tend to worry more about the volume of water that you might ingest from the drinking water rather than the water that you inhale. It is true that you do sort of breathe in a small amount of water, especially if you take a long hot shower. So there is that potential. I guess I'm inclined to say that unless your water has really high levels of PFAS, it's probably not going to be a substantial contributor, but I guess you can't totally rule that out. And just as an additional point, again, of these 9,000 different PFAS chemicals, some of them are what we call volatile. So that means that they can tend to be end up in the air. And so if you happen to have volatile PFAS in your water, I guess it's possible that they could end up being breathed in while you're taking a shower. But I guess my initial reaction would be to think that the water that you drink is going to be much more important for exposure.
Great, thank you. And a question that several people had, Laura talked a bit about, or did talk about gardening and fertilizers and PFAS, but how about when you water your vegetable plants with contaminated water? Will the PFAS get into the vegetables? It's either you able to respond to that.
I'll take a first pass and then Laura may have additional information. As a lot of the answers to these are, it depends. It depends on what type of plant you're talking about and the specific PFAS chemical that you're talking about, and probably a bit about the type of soil that you have as well. In general, the shorter chain PFAS, so the ones that are used as replacements, tend to be more mobile. They just move around more easily. So if you have the same amount of a long chain and a short chain PFAS chemical in the soil, you're more likely to see that end up being transported within the plant and end up in the leaves and the fruits and shoots of a plant, whereas the long chain ones don't move around quite as much. So I'd say in general, the root-based vegetables might have more than sort of the ones where you eat the leaves or the fruits, and the short chain ones are more likely to end up moving up into the top parts of the plant.
Great. So I'll direct this question to Laura. You advise to limit the time that takeout food is stored in food packaging, but what about supermarket non-takeout food? Any recommendations on how to do that?
Well, what I have heard, and Laurel, please correct me if I or add to what I'm saying, in the testing that we have read about, and much of that testing was done by Silent Spring, some was done by the Ecology Center. Most of the food packaging with PFAS was not supermarket paper packaging. The only place where, the two places, unfortunately for me, as someone who really loves sweets, the two places where PFAS may be in a supermarket is a bakery bag, like you get a muffin, you put it in a bakery bag and maybe it's coated with something. And also the plates that are underneath cakes, you know how you can sometimes go to the supermarket and get a frosted cake and it's got a sort of a plate on the bottom. Those are two places where PFAS has been seen. The other place, if you have a supermarket like Whole Foods that has a salad bar, so that the paper packaging that Whole Foods had a year ago did have PFAS. It doesn't anymore. So those are the three places to look. But yeah, I wondered, like, well, what about, I have a pizza and it's in a square box. To my knowledge, and I think from our network, that is not, those have been tested. And the one, again, not everyone has been tested, but the ones that have been tested have not been found to have PFAS. Is that?
I would say that's a good summary, Laura. And in response to one of the other questions specifically about parchment paper, I put a link to a report a study that was conducted by Toxic Free Future and Safer Chemicals Healthy Families, and they tested a number of samples from grocery stores. Again, not comprehensive. I think they tested around 100 samples. And the types of products you mentioned, Laura, are those, especially the molded fiber used at a hot bar. I guess grocery stores don't really have those active right now, but in general, the like grocery store packaging didn't really seem to have a lot of people, did not seem to frequently have PFAS.
Thank you both. So another couple of questions, kind of getting more into the science side of it. What does the presence of one type of PFAS tell us about the likelihood of any of the other 9,000 being present? Dr. Schaider.
Sure, I'll take a pass at that. So it depends on what the source is. So for instance, if it's a firefighting foam related source, you might see a few stand out from the kind of conventional water testing that we do. In general, when water supplies are tested, there's about 20 or 30 chemicals that are targeted specifically. But for instance, in firefighting foam, we know that there's a mix of a lot of different PFAS chemicals, and each one can move through the environment a little bit differently. So if you find PFOS or you find some of the other ones that we target, it suggests that there might be other ones present as well. These aren't usually found one at a time, but it can be hard to predict what those other ones are. There are some evolving chemical analysis methods that can provide some clues about the total amount of PFAS in a sample. So for instance, how much fluorine is there that's bound up in an organic or carbon containing chemical. And you can kind of compare that total amount with the PFAS plus PFOA plus the other ones and get a sense of how much PFAS we're missing. There was a study of surface waters on Cape Cod that used that kind of a method and found that about half of the PFAS couldn't be attributed to sort of known PFAS chemicals. So we're getting a piece of the puzzle with the testing that we're doing, but there are definitely other ones that we may be missing.
Two other things. I read something yesterday that not all 9,000 chemicals are used in commerce. Do you have I had read a number of about 600. I don't know if that's, one of the challenges is that we don't have testing methodologies for all of the PFAS yet. So we're testing for a fraction of them. We don't yet have an ability to test for all of them.
That's right. And even the ones that are used in commerce, and I don't know the exact number, but I would believe that it's on the order of hundreds and not thousands. Not all of them are going to be moving around in the environment. Like PTFE is a large molecule. That's the Teflon chemical. That's not going to be in your drinking water. That's not going to be migrating around in the environment. So it is a subset of these that are likely to be moving around, but we don't even know what they all are. The chemical companies that manufacture them don't have to disclose them. And the labs that are testing water samples or soil samples don't have an analytical standard for each one. So it makes it difficult for them to calibrate their machine and really verify the identity and the amount of each individual compound.
Thank you. So we want to thank the chair of the Hanscom Field Advisory Commission for being here tonight. And he asked a question about PFAS and airport firefighting foam. And so specifically, are there PFAS-free fire suppressant systems that are being promoted as viable alternatives by fire departments?
Sure, absolutely. So there are fluorine-free foams that are available, and they are being used at airports around the country and around the world. And my understanding is that they have a similar level of efficacy for fighting fires, and that for most applications that they can be used instead. There's been a shift away from foams that contain long chain PFAS, but many of these have a C6 or a different PFAS type of compound. So switching just from the long chain ones isn't really addressing the totality of the PFAS issue, but there are fluorine-free foams that are being used by fire departments and that can provide similar firefighting efficiency. And I'd be happy to follow up with more resources about that specifically.
Great. So a couple of people asked questions kind of along the lines of what levels of PFAS really should we be concerned about? So, you know, the difference between 20 parts per trillion and 70 parts per trillion, what's really the, yes, 20 is better, but what's the practical difference to my health, and does that depend on my age? And another person asked if somebody has a lot of PFAS in their body, what's the probability of getting some disease as opposed to probability with a much lower level of PFAS? Dr. Schaider, can you speak to any of those sort of levels and probability questions?
Yeah, and they're all kind of related there. And I could give a whole separate talk about like what goes into creating a drinking water standard, like how do we come up with a single number? And there are a lot of assumptions that that risk assessors use to develop those. So they start with the science, they look at the published studies, usually results from animal studies, but they can also be informed by epidemiological studies in people. And from that, they look at the weight of evidence and they identify a level, either the level that the lowest dose that causes an effect in there, for instance, in a study of laboratory rats, or the level that is associated with no detectable harmful effects. And then that's sort of used as a jumping off point for a series of calculations that also take into account things that we don't know in terms of the completeness of the data that are available on health effects. They take into account uncertainties in extrapolating from laboratory animals to people, and to account for the fact that some people are a lot more sensitive than others. And we also try to take into account the fact that we don't only get exposed to PFAS from drinking water, we can be exposed in other ways. So if we come up with an amount of PFAS that we think won't cause harmful health effects, we don't want to use up that whole allowance just on drinking water, because we can be exposed in other ways. In terms of who's most vulnerable, in general, exposures during pregnancy and during infancy are thought to be most harmful because our bodies are developing and rapidly changing during those sensitive periods of time. So really, when we're coming up with a drinking water standard, we're aiming for a level that over population's entire lifetime will not cause harmful health effects. And there's some different assumptions if you're talking about chemicals that cause cancer versus chemicals that are associated with other types of harmful health effects. If you're talking about one specific individual, it becomes a little harder to know, like, am I personally at some greater increased risk of disease or not? It's really intended at a population level to protect everyone. So I would say that if you're younger, that you are more vulnerable than someone who is maybe only recently been exposed later in life. And then in terms of is there a certain level of exposure at which I'll be at greater risk of disease? Those exact numbers are hard to evaluate. Oftentimes there's a trend where in a study of people, you'll see that people with higher exposures generally have higher risk, but there's not a certain sort of cutoff where if you're above this certain amount, then now you'll have a higher risk. So I'd say the goal for the regulations are to just reduce risks as much as possible and to protect people over the course of their whole lifetime.
So I think we have time for just one more question. Actually, I'm getting a chat. We'll maybe have a couple. Might have time for one or two more after. I think there's several questions relating to how PFAS gets to the drinking water wells and whether we can figure out what that source is through testing.
So yeah, that's a great question. And like I said, others here might have more specific information about what's known about sources in Wayland or specific other communities. There are approaches called chemical fingerprinting where you can look at the relative amounts of different PFAS chemicals. And I gave kind of a little simplified example of that Typically in the water testing that's done, we're looking at 20 or 30 different chemicals. And so, like I said, you might get some clues in some cases if you have really high levels of certain specific PFAS and very low levels of others. That might give you a clue. Is it more likely to be a kind of Teflon related source or a firefighting foam source? But it's not definitive because every type of foam had a slightly different mix of different PFAS chemicals. In some cases, there might be some very specific chemicals that are just related to a chemical manufacturing site. So for instance, in North Carolina, a former DuPont plant now called Chemours switched over from using PFOA and creating Teflon and used other what we call Gen X related chemicals. And so there are some specific chemicals that seem to be found in that community that are not really showing up in water supplies in other places. So that might provide a clue in that area about the extent of contamination from that one source. But if you see sort of a mix of different PFAS chemicals, I'd say it might be hard to really definitively point your finger at a certain source. There might be other types of chemicals that you might use as well from not the PFAS family. So a lot of my other work looks at other types of emerging contaminants like pharmaceuticals or artificial sweeteners or nitrate. And so that might give you some clues like, does this seem to come from wastewater versus other types of sources? So I'd say it can provide some clues, but it might be hard to get a really definitive answer about a source, except in some specific cases.
Great, thank you. So I just want to remind everybody to take the action that Laura mentioned, and I'm going to go ahead and put it here in the chat again. So please do oops, I just copied and pasted. I didn't copy and paste the right thing. All right, I'll do that after I stop talking. Back in the chat, there is a link to take the action. So please make sure that you do that to write to your legislators tonight. And I think the very last question we will have time to address now is it recommended to screen yourselves or your families for exposure and bioaccumulation?
So this is another question that we commonly get. People want to know about their own personal PFAS levels in their bodies. And I think that having that kind of information, especially if your water has had high levels of contamination, can be useful. It can be something that you can hold on to and keep as part of your medical record. It's not like getting your child's blood tested for lead, where there's kind of a number that we use, and if your child falls above that, there are certain actions that your pediatrician might recommend. It can be it's currently difficult to obtain kind of individual blood testing. Sometimes medical providers will help provide that kind of information, but it can be difficult to obtain that. There is a tool that's been developed by Scott Bartel at University of California, Irvine, which allows you to predict what your blood level might be based on water concentrations and what we know about how long chemicals like PFOS and PFOA can stay in our body. So that can give you sort of an estimate or a ballpark of what your individual exposure might be. So, I think it's a very individual decision. Some people feel like they want to have that information and they want to know. And I'm happy for people who are interested in that to try to find resources, but it's not easy, and typically people have to pay out of pocket for that type of test.
Wonderful. Well, thank you very much to Dr. Schaider and to Laura, and apologies to those whose questions we did not have a chance to answer, but this has been a very informative evening and great to have your discussion at least through Q's and A's, and we look forward to a day when we can do these discussions live. So thank you very much to the Metro West Climate Solutions for organizing and hosting this event, and to all of you for sticking through to the end. And I will pass it back to Jeff to close us out.
Just thank you very much, all of you, for attending and for participating. This was fantastic, great information, overwhelming amount of information. As I noted, there's a recording of this program on the Metro West Climate Solutions website, along with some links that I've been trying to gather as Dr. Schaider and Laura Spark have been speaking. And stay tuned. We will be back in September with another program for our growing group of members and followers. So thank you very much. Have a good night. And throw out your Teflon pans.